Mr. Harris here, and welcome to a new video of Unit 10. In this video, we're going to talk about how metals were discovered and how it was related to the ease of extraction. So without further ado, let's begin. Have a look at the timeline in the diagram over here. You'll notice that gold was one of the first metals that were discovered. And sodium, magnesium, aluminum, these metals were discovered rather recently actually. So how can you relate these metals to the ease of extraction? How are gold, silver, how are these metals extracted? Yes, these metals are extracted by heating them alone, right? Heating their ores or oxides alone. How about the metals on the right side of the timeline? How are they extracted? Yes, they're extracted by electrolysis. Now, do you notice something? The metals that were discovered 6,000 BCs or 5,000, 4,000 BC, these metals were relatively easier to extract because, of course, they're easy to extract. That's why. And for the metals that were more difficult to extract, like sodium, magnesium, aluminum, zinc, at that time, for example, in this period of time, people didn't even discover about electricity. They had no idea what electricity was all about. But it's only rather recently is when people started to discover about electricity, people started using electricity, and that's how they figured out that they could extract these metals from their ores using electricity. But for metals like gold, silver, because they're rather unreactive, so it's pretty easy to get these metals. And for metals such as copper, iron, lead, as we all know, they're extracted by the second method. What's the second method? Heating with carbon or heating with carbon monoxide. Since these metals are moderately reactive, it also took some time for people to discover and extract them. All right, let me go ahead and write that down. Moderately reactive. All right, so now you can understand why some metals were discovered much earlier back in time, while some metals were discovered much later. All right. However, do you guys think that metals will last forever? The answer is no, because we're using metals everywhere. Over here, you'll notice that iron only has around 55 years remaining of stock or reserves. So what can we do to conserve these metals over here? How can we make them last longer? So one very simple thing to do is we can reuse and recycle metals. So our concern is, as chemists, we want to know what are the pros and cons of recycling. I'm sure you can read by yourself this part, but I'd just like to remind you that the pros is, of course, we can conserve it, we can conserve the metals, and less energy is used when compared to extracting new metals. However, the cons are related to one main word: cost, cost, cost. So it may be more expensive for us to recycle and reuse them. All right, so make sure you read through this part by yourself. And let's do some questions now. Very simple questions. The table given below gives information about the extraction of some metals. So you have gold, zinc, and sodium. Explain why gold is found in free state in the Earth's crust. So they're asking you, why is gold just lying around on the Earth's crust? Why isn't it reactive or so? So I just used the word. So gold actually is, as I mentioned in the previous slide, gold is unreactive. Because gold is unreactive, we can use a process called panning. Remember I talked about what panning is? I showed you a video how you can get gold from this using the method of panning. Question B suggests how zinc can be extracted from its oxide. So zinc You can refer back to the table, the metal reactivity series. Based on the metal reactivity series, zinc would be using, yes, method 2. So what is method 2? Heating with carbon or carbon monoxide, right? All right. Let's see question C. Oops. Sodium is one of the most abundant metals in the Earth's crust. Explain why sodium was not extracted until 1807. So, in other words, why did it take so long for us to discover the metal sodium? Yes, I've just mentioned in the previous few slides. Sodium, what process does it use to extract? Yes, we use electrolysis. Now, because let's have a look over here, sodium is very reactive. It can only be extracted by electrolysis. Or you can also mention its extraction had to wait for the discovery of electricity. So this usually is a 2-mark question, 2 marks. So 1 mark would be given if you mention sodium is reactive, and the second mark would be given that it's extracted by electrolysis, or you can mention that the extraction had to wait for the discovery of electricity. All right, simple enough. The amount of copper-rich ores is estimated to last only a few more years. So this is about metal conservation. New houses need several kilometers of copper wires. Suggest 2 ways in which society could improve this problem. 2 ways that we can overcome the problem of metal conservation. So very simple. Always remember the first one that you need to answer is you can recycle and reuse. All right, that should always be your first answer. What's the second answer? What could it be? You can actually just substitute the metal or use some metal, right? Substitute the metal or use some other metal. All right, so here are some examples. So reuse, recycle, use low-grade copper ores, or use other metals, or any specific answer that makes sense. It will work. All right. So that's the end of this video. That's also the end of Unit 10. So we'll be starting Unit 11 in the next one. All right, that's the end of this. I'll see you in the next one. Bye.